Okay, so you've learned about the slope of a line, but having just the slope of a line isn't enough. So far, the lines have been given to you on a graph, and you've calculated the slope of those. But what if all you had was the slope of the line? How would you graph it? So we're going to talk about graphing a line given any point and the slope. So in the previous think, pair, share, you were asked, what is the connection between the slope you calculated and the points on the line? And the answer was, there is the same rise and run between each point on the graph. So here on the left-hand side, so even if the slope of the line is known, so for example, a slope of negative 2/3, but any point on the line is unknown, one cannot figure out exactly where the graph of the line is. So each of these lines, so we have line alpha, beta, gamma, and delta. Each of these lines has the same slope. They all have the same negative slope. But without knowing a particular point that the line goes through, we can't nail down the line to any particular location. If all we know is the slope, there's an infinite number of lines that are available. So we at least need to know a point. Okay, so, but if both the slope and a point are known, then the known point gives you the fixed point you need to start applying the slope, and so draw the line. So even though we have all of these lines with the same slope, once we have a given point that the line has to go through, it's going to lock us down. It's going to lock the line down to one particular place because it has to go through that one point. All right, so that's kind of where the title of the section is graphing a line given any point and the slope. We've got to have both. Down here on the bottom left, there's kind of an observation I wanted to make about these four lines, is that the slopes of all four lines are equal, and any two lines are considered parallel if they have equal slopes. So all of these lines are parallel because they have the same slope. All right. So now in this think, pair, share, we're going to graph a line given the slope and a point on the line. So this is a think, pair, share, but I'm gonna get things started and then move away, or actually then pause the video and then see if you can figure out the rest of it using the pattern that I'm about to show you. Okay, so we know it has to go through the point 3, 0, which is right here. Now it has a slope of 3/4, which means slope is rise over run. So we have a positive rise of 3 and a positive run of 4. So just like in the previous example, once we have a given point, we can kind of go out from there and get the other points on the line. So since we know that this has a positive rise of 3, in order to go from this point to the next one, we can go up 3. So that's a rise of positive 3. And then we can do a run of positive 4. And that's where our next point is going to be. All right, pause the video here and see if you can find where the next point is going to be. All right, so hopefully you gave that a try. And so the next point is from this new second point we made, we're going to do a rise of 3 and a run of 4 and put another point. All right. And we can go the other direction. Now, notice that this is so our slope here is positive. Well, we would get a positive slope also if we had -3 over -4, right? Because a negative over a negative is a positive. So we could have a negative rise. Oops. We can have a negative rise of 3 and also have a negative run of 4. So let me do this in a different color. So I'll do this part in green. So from this point here, we could have a negative rise of 3 and a negative run of 4 and put a point. So this would be a rise of -3 and a run of -4. And we could do a negative rise of 3 and then a negative run of 4. Make a point. Negative rise of 3, negative run of 4. And so once we had a starting point, okay, which was this one right here, we could apply the slope iteratively and find more points that were also on the line. And you'll notice that if we connect the dots, these all line up. Because we had a known point as a starting spot, and we could just apply the slope to that starting spot.